This video is for section 10.2. In section 10.1, we studied square root radical functions, and we saw that square root radical functions have this steady arc shape where one end of your arc has an arrow, meaning it goes on forever, and the other end of your arc ends in a point. Okay? And we saw there are lots of bells and whistles we could add to your square root parent function to make all these possible changes happen. We could have a horizontal translation, a vertical translation. You could do a reflection over the x-axis. You could have a reflection over the y-axis, a horizontal stretch or shrink, and a vertical stretch or shrink. These changes all depend on where you place the number in your square root radical function. Today, we're going to be looking at cube root radical functions. Very similar to yesterday, but instead of having the square root of our input, we'll now be doing the cube root of our input. All right, so let's look at this example here. Graph h of x equals cube root x minus 4. Compare to f of x equals cube root x. Okay, so they're wanting us to compare h of x to this parent cube root function. Remember, the parent cube root function is the most plain Jane cube root function out there. Okay, so I suggest we start by graphing this plain Jane cube root function, see what it looks like, and then we can go ahead and graph h of x and compare the two. Okay, so to graph this cube root function, I'm going to make an input-output table. Okay, and in section 10.1, you guys had to be extremely careful with never putting negatives under your square root symbol. On your calculator, if you try to take the square root of a negative number, it's going to tell you error. However, you can do the cube root of a negative number. So we are allowed to put negatives under this cube root sign. Okay. So when I choose my inputs, I want to choose numbers that are perfect cubes so that my outputs are whole numbers. Now here's a list of the first couple perfect cubes. If you take the cube root of 0, you're going to get 0. If you take the cube root of 1, you'll get 1. If you take the cube root of 8, that's 2. Because 2 times 2 times 2 gives you 8. Again, today we can put negatives under our cube root. The cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. Right? So these are the types of inputs I'm going to be going for so I can get whole number outputs. All right, my first input that I'm going to use is that negative 8. That's a perfect cube. And then I'll just go through some of the other perfect cubes, negative 1, 0, 1, and 8. Okay, if I plug in a negative 8 into f of x, I'll get a negative 2 as my output. The cube root of a negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1, and the cube root of positive 8 is positive 2. Okay, so I can go ahead and graph these points. Okay, so I've got negative 8, negative 2 down here, -1, -1, 0, 0, +1, 1, and +8, 2. This is going to be the shape of my plain Jane parent function, my plain Jane cube root parent function. Obviously, this shape is different than the square root function. Okay, we are allowed to have negative inputs as well as positives. That's why the shape continues with arrows on both sides, unlike yesterday. Okay, we also have to graph h of x. Now, I know from past chapters and also from the last section that putting a -4 at the very end of my equation, that's going to cause a translation 4 units down. Okay, so I'm expecting to see that when I graph h of x. Now I'll make an input-output table for h of x. Again, I'm going to use all my perfect cubes as my inputs. Okay, the cube root of -8 is -2. -2 minus 4 is -6. The cube root of -1 is -1 minus 4 is -5. The cube root of 0 is 0 minus 4 is -4. The cube root of 1 is 1 minus 4 is -3. And the cube root of 8 is 2. 2 minus 4 is -2. When I go to graph these points, -8, let me add some more points here. -8, -6 is down here, -1, -5, 0, -4, 1, -3, and 8, -2. This would be the graph of h of x, which we can see h of x is a translation 4 units down from f of x. Okay, this example is a little more complex with all the things, all the bells and whistles we've added in here. Let g of x equal 2 times the cube root of x minus 3 plus 4. Part A, describe the transformations from g of x to f of x. So from the parent function to g of x, what changes are we expecting to see? All right, so let's start with the number right out front here. If you have a number out front of the square root symbol, that's going to cause a vertical stretch. Okay, this is my A, 2 is my A, and because A is greater than 1, it's going to be a vertical stretch rather than a vertical shrink. So this would be a vertical stretch by factor of 2. All right, the next change thrown into this equation is the -3 underneath the square root symbol. If you have a number added or subtracted underneath your square root, that's going to cause a horizontal translation. So this is going to be a horizontal translation 3 units right. Okay. When you pull this number out of the equation, it is a +3 rather than a -3. Okay. When you're in the coordinate plane and you're going +3 on your x-axis, you're moving to the right. Okay, the last thing added to g of x is this plus 4 at the very end outside of the cube root symbol. This is going to cause a vertical translation. Okay, and it's going to cause it to go up 4 units. Okay, so these are the answers to part A. These 3 numbers cause these 3 changes to our parent cube root function. In part B, we need to graph. So I'm going to make an input-output table. Okay, and again, whatever is under my cube root, I want that to be a perfect cube so that I'm working with a whole number rather than a repeating decimal. Now, one of the first cube roots I'm going to try to shoot for is a -8. Now, I know that -5 minus 3 gives me -8. So I want my first input to be a -5. -5 minus 3 is -8. The cube root of -8 is -2. -2 times 2 is -4, and -4 plus 4 is 0. All right, the next perfect cube I want to shoot for, I've already done the -8. Now I want to try to get a -1 under my cube root. I know that 2 minus 3 is -1. So my next input will be a 2. 2 minus 3 is -1. The cube root of -1 is -1. -1 times 2 is -2. And -2 plus 4 is 2. All right, the next perfect cube I'm going to shoot for, I've done -8 and -1, then I'm going to do 0 next. I know that 3 minus 3 makes 0, so my next input will be a 3. 3 minus 3 is 0. The cube root of 0 is 0. 0 times 2 is 0. 0 plus 4 is 4. Okay, and then 2 more inputs I want to plug in here. Now I'm going to shoot for a +1 and a +8 under my cube root. I know that 4 minus 3 is +1. So my next input will be a 4. 4 minus 3 is 1. Cube root of 1 is 1. 1 times 2 is 2, and 2 plus 4 is 6. Okay, and again, the last cube root, perfect cube I'm going for is 8. I know that 11 minus 3 makes 8, so my last input will be an 11. 11 minus 3 is 8. 8 cube rooted is 2. 2 times 2 is 4, and 4 plus 4 is 8. Okay, so now going to graph. Okay, my first point is -5, 0, which is right here. My next point is +2, +2. Then +3, +4. +4, +6. Okay, and lastly, +11, +8. This is the shape of g of x.